Hi and Assalamualaikum. My name is Nur Hidayah binti Muhammad Azim. Our title project system is Electronic X-ray Records. Without wasting any time, I will present Chapter 1, Planning. Introduction. The purpose of this document is to build an online system to digitally manage the patient's record system for government health clinics in Malaysia. This document serves to give an in-depth insight of the digital record system by defining the problem statement in detail. It also concentrates on the capabilities required by the stakeholders and their needs while defining high-level product features. Next is background. Electronic X-ray records are increasingly being deployed as digital inpatient information systems of clinical and administrative data. The interaction of social and technical factors is important when considering effective implementation and adoption strategies in busy, complex clinic environment. These systems offer considerable potential to enhance the safety, quality, and efficiency of an X-ray patient's record process in clinic healthcare provision. Then, for intended audience and suggestions, this document report read by stakeholders, project manager, users, software architect, software engineer, testers, and documentation writers. The Software Requirement Specification or SRS has been organized in order of increasing specificity. Next is project scope. This system is provided for staff to view the patient's X-ray data. It can make staff work become easier and more effective. The system can do many functions, such as insert, update, delete, save, and print the patient's record. The integrity of the system will be more secure. Patients will not need to waste their time to register for each time they come because the system can keep track of their past records, so they will not duplicate data or records. The doctor will receive the patient's data after the X-ray has been done. Not only that, they also can view the data about their patients. This can enhance the communication between the doctor and patient because it has been reviewed first by the doctor. Objective: to save patients time, to avoid data redundant from happening, to ensure the security of patients' data is guaranteed, prevent the missing of patients' data. Problem statement: waste time for patients to fill information, may occur redundant data when using manual system, data about patient might be missed, security of patients' data. So model to be developed in this system is one of it is patient registration scope. Patients are able to register first before the treatment. Next is staff management scope. Staff are able to log in, manage patient data, such as insert the patient's data, search the patient data, update, and send patient data to the doctor. Next is radiological record scope. So it's able to manage patient's film X-ray result. And doctors are able to receive patient's data, view patient's data, and add feedback. For project schedule and costing, the maximum timeline of this project will take 3 months, which means 15 weeks. For overall cost of this is estimated to be approximately Rm 100,000. Labor cost, the budget will be around Rm 50,000, while for overhead fees is estimated around Rm 50,000. Moreover, total working hours is 600 hours for each worker. Next is software development model. We use Pyramid model in this project. Data collection methodology: generally we use structured questions such as interviews and questionnaires to collect data for the project. By questionnaires method, we collect information about patients, while for interviews method, we ask staff to obtain a general understanding of the business process.
My name is Nurhanis Afifah and I will present about requirement analysis. So, electronic X-ray records, or EXR, are increasingly being deployed as digital inpatient information systems of clinical and administrative data. The interaction of social and technical factors is important when considering effective implementation and adoption strategies in a busy, complex clinic environment. These systems offer considerable potential to enhance the safety, quality, and efficiency of an X-ray process in clinical healthcare provision. Okay, next is SE system. SE system is the current system being deployed, whether it already use a computerized system or manual system. So we have 4 modules. We have first, register patient. Second is user management. Third is do X-ray, and the last is do consultation. Okay, for register patient module, it will register a patient before X-ray and consult a doctor, and this will be done manually using a form. For user management module, basically it will manage the data about the patient. The staff will need to keep the file safe from unwanted incidents such as data loss. When we use manual or handwritten, the ink will be easily disappeared, so the data loss will happen. So we want to prevent this from happen. The staff also need to go through the patient's file one by one. Next is do X-ray module. The staff need to give the result of X-ray manually to the doctor. Next is the consultation module. Okay, the doctor will receive the patient's data and result manually from a nurse. Next is 2B system. 2B system is a system that we want to improvise from the current system. Okay, we also have 4 modules, and 2B system is to make the life easier and the work become more efficient. So next is functional requirements. First is only authorized doctors can approve the imaging test or the X-ray test. Second, only authorized staff can edit or update patient's record. The system must ensure that only authorized users can access it. The system should be able to sum up the total number of patients. The system shall generate report on total profit gain. Patient can view their feedback on tests given by the doctor. Next is non-functional requirements. Okay, first, the system should update patient's imaging tests every 10 minutes. This interaction between user and system shall not exceed 5 seconds. The system should be able to integrate with pharmacy, radiological information system, and laboratory information system. The system shall notify administration if any intruders try to change the data. The system attendance limit must be scalable enough to support 500,000 users at a time. The system should work on any platform. Okay.
I am Sharato Najiha who would like to present about Chapter 3, System Analysis. In this chapter, we have use case specification and sequence diagram. First, use case specification is a document used to capture the specific details of a use case. Use case specifications provide a way to capture the functional requirements of a system. They are useful tools in communicating with project stakeholders, system users, business analysts, and developers. I only show you one of our use case specification for our project. This use case specification is for authenticate user use case. First, name of the use case is the authenticate user. Next is the description. This use case is used by staff or doctor who want to log in into the system using their ID and password, so we can trace who are in charge for that patient at that time. Next is the precondition, staff ID and doctor ID to log in. For the post condition, the information is saved in the database. Flow of the events, primary flow. First, the use case starts when the user selects the login menu. Then the system will display the login menu. The user inserts their ID and password. Then the system verifies and validates the user's authentication. The system acknowledges the user is existing and displays the details of user's panel according to user who logged in. Last, the use case ends. For the alternative flow, press cancel button. For the exception flow, if the user does not enter the correct authentication, the system shall ask the user to re-enter the correct authentication, either username or password. Next, for the rules, the user needs to insert the correct authenticate. Last, for the constraints, the system should have access to the network in order to log into the system. Next is for the sequence diagram. A sequence diagram shows object interactions arranged in time sequence. It depicts the objects and classes involved in the scenario and the sequence of messages exchanged between the objects needed to carry out the functionality of the scenario. This is one of our sequence diagram for our project. The sequence diagram is for register patient use case. The actor is the patient. Register menu is the boundary. The system is the controller. Patient information database is the entity. First, patients need to select register menu. Then request registration screen. Then the system will display the registration form. Then the patient needs to insert their information. Then the registration will be saved in the patient information database. And last, fetch record. That's all for the chapter 3.
Okay, I will continue the presentation. My name is Nur Afika binti Manaseh. I will explain the content in chapter 4, System Design. For introduction, the objective of this chapter is to describe the high-level design and detailed design of the proposed system. The high-level design describes the detailed design of package and classes involved in the entire system, while the detailed design describes the detailed design of classes and operations that involve the entire system. System overview. The figures show the system overview of this system interface with the patient, staff, and doctor. System architecture. Static organization. There are static organizations that organize into 9 main package switches are shown in the figure. Then the figures show the package interface for this system. System state and mode of the electronic X-ray record were encapsulated into the 9 use cases identified in the software requirement specification. Number 1. The related use case for package patient registration is patient registration record. Number 2. The related use case for package consultation are consultation record and retrieve patient record. Number 3. The related use case for package laboratory are order type and lab result. Number 4. The related use case for package code maintenance is manage code. Number 5. The related use case for package radiological is radiological record. Number 6. The related use case for package pharmacy is drug type. Number 7. The related use case for package database maintenance are managed database patient and doctor. Number 8. The related use case for package security is authentication user. Number 9. The related use case for package result are patient and laboratory result. Design description. This is the communication of CSC security with other CLS. This is the communication of CSC registration patient with other CLS. Platform-specific architecture. Electronic X-ray records use J2EE platform. Servlet will play a significant role in the creation on our web application. Eclipse is the framework of this system. The system uses MySQL version 5.6 as the open source database. In the data dictionary that states all the data type used within the system is depend to programming language and define each attribute. Data dictionary. Table shown patient information. Then table shown doctor information. Next, table shown pharmacy information. Other than that, table shown radiological information. Last but not least, table shown laboratory information. That's all from me. Thank you.
That's all from us. Thank you.